Hello, testing the audio. Hello, testing the audio. Oh, okay. You start the class. First, I want to thank some of you already submitted assignments to me, and that's very encouraging to me. Very encouraging to me. I see your hard work, and it's also helpful for me to prepare my lesson and to be more targeted to the problem you have. Last week, we left a problem. When we defined the set, we said that set only allows individual single numbers, doesn't allow duplicate numbers. However, we were able to define a set with duplicate numbers. So after a little bit of research, I find that this probably a defect of this class. It allows us to create a set with a duplicate number, but it actually only stored the non-duplicate number. So if I check the length of the set, for example, here I have the set, and if I check the length of the set, they only have 3 elements. So because of this feature of a set, it's often used to join multiple lists. You can change the list to a set and join the set, and then it will remove the duplicate number. And also, I want to mention the notation in Python. There are 2 ways to add text. One is just add comments, like what you do in Python. Add comments, short comments. And the other way, in Jupyter Notebook, it also allows you to use the Markdown. You can also use the Markdown to write text. And if you run this, then it will be saved as a text in your report. And you can also use headings. For example, this is the list. And then there will be a heading in your report. So this is real helpful when we structure the report. How we use these 2 different types of text. Usually for this Python comment, it's usually used for short text and to add comment for the code to explain the code. So it should be short and just 1 line. Yes, Candy.
And one, like, first page, you can use Python and Markdown for like 2 different
Yes. Yes. So in the code, when you are writing the Python code, you just add a pound key and then the comments. And if you want to switch to Markdown, you have to choose Markdown. Okay. And Markdown is usually used to write long paragraphs. When you later write a report, you want to explain the result like that and add narrations. Then in those situations, you use Markdown. Okay. Next, we'll go to conditional statement. I guess most of us are familiar with the if-else conditional statement. Now here I write a very simple if-else statement. So we want to enter get a student score and then print out, change it to his or her grade, the student grade. So this is a very simple statement. I can run. I can run to print out the result. So if we look at this code, how can we improve this code? First is just something about writing code. The simpler your code is, the better. So here, there's a lot of repetitions of a print. So it's a lot lengthy, and we can use a variable like grade to assign the grade to this variable. And then at the end, you can print out this variable, the value of this variable. So one thing we can do is to remove all these sentences and instead use a grade. And for all operators, leave some space between the operator and the variable. So here you can, instead of print out everything you can with these, so on. And another thing we see is that it covers the multiple numbers, but it doesn't cover like the score is if the score is below 0, like those. So, and also oftentimes a common problem we have is when we write this if else, we are not sure if it covers those boundary values. It covers 90, 80, 70, and those boundary values you easily get wrong, get errors. And I see that's a common problem in your submissions. So an easier way to check it, to check whether your statement covers all the possible number is to use the number line. For example, here in this we cover score larger than 90. So score above 90. So we use this to cover 90. And then use next one is the else if. So else if score larger than 80. Then else if means excluding score larger than 90. So it covers all these numbers. And so when we write this score above 80, okay, this covers from 80 to 90 for this condition. And then goes to next, covers the score above 70. And that covers everything under 70. Also, it's good to use this number line to structure this in a logical order, and instead of jumping from like a number above 90 and then you jump to 70 to 60, that's not a good logical order. So it's better that your conditions follow this logical order. And another problem I see is some of you use if score above 90 and then else if score above 80 and score under 90, because you just want to get to this part. You just want to get to this part. So you write else if score above 80 and below 90. So that's a difference between if and else if. When you write else if here, it's already excluded this part. So you only talk about these numbers. So you don't have to write the second condition, the variable is above 90. It's already excluded. But if you are writing if score is above 90, and then you can write another if. If you use another if, then you have to add the condition, score condition that is above 90 and smaller than 90 and bigger than 80. So that's a difference between if and else if. And okay, another problem I see is that when you write if score above 90 and then change here to just do this one now. And it change this to write all the if you change these to if instead of else if, what will be the result? What will be the printed result? So for example, I give a number. Like 81. What will be the output? Yes, it will go all the condition and it will print out grade is A. It's above this it meets the requirement. Score is above 90, so it will print out A and it will print out B as well. And in the number line, if you see from the number line, the first condition is if you meet all the condition 81, so you go the first condition if 90 goes here, and then you do if 80, then this goes over here. Instead of if else, it accrued this part, and the second condition else if it only saves this part. So that's the difference between if and if else. And when you write this statement, you have to be careful of that. And always use some boundary value, 80 and 70 and all 0 to test your code. Next, we are going to talk about loops. There are two types of loop, while and for loops. So in what situations we use while, and in what situation we use for loop generally.
If you don't know how many times you want the loop to execute, use a while. If you're like counting from the list, you can use a for loop.
Yes, correct. So when we know how many times we need to iterate it, we use we use a for loop. For example, you want to iterate a list or iterate from a number 0 to 20, you use for loop. And if you only know the condition when you have to stop, and then you use a while loop. So here I write a statement. Okay, you input the score, and then you want to input the score until the user quit. Press 0 to quit. You can do this, and then scan another score until the user quit. So in this way, we can enter like multiple times. And on the other side, if we know we need to enter 20 students' names, and then we write a for loop for I in range here. And we're familiar with this range. So usually, like how we index this, we mentioned the last lesson. Usually, you start with this number, and this is included, but the end number is usually not included. So for example, this loop, if I print it out, it will be from 0 to 19. But it's still 20 numbers. So in this way, for this loop, we can scan like 20 students' scores. So that's how for loop is used. And also we can use for loop for list, iterator list. For example, I have a list here. And then I can also use a for loop to iterate all the elements in the group in the list. So when you write this loop, this I will represent all the elements in L. So this loop in a list or in a dictionary, it all works the same way. And another alternative way to loop the list is that you can still use a range. But this range you could use from 0 to the length of the end number and the element of the loop. And the element of the list. So it would be the length, the list, and then you can also iterate the numbers. For example, I can get to the and then this range will be and in this way I only represents a number. It doesn't represent the element in the list. So you cannot print out I instead of you print out the list with the position. I only represent the position, but it also works. Of course, we want the code to be shorter, and we use the first way usually. Okay, I want to mention the last question in our assignments. I ask you to pop up the item after you print out each element, and most of us have no problem to print out the item, but have difficulty to pop out each element. That's because when you write the loop, if you pop up after you pop up each item, this dictionary is changing. So this range, it will change. It will be shorter, and report the error. You have changed the size. The dictionary is changing the size. I will not let you proceed. So make sure the range is stable. And here the list should be stable. So the solution for our assignment is you could create a list, a copy of the dictionary for this loop for this condition. And then in the loop, you could pop up each item. Next, we're going to talk about the functions. So I've written this code here. I use my code for the score. I've written this code here to change the score to grade. Still want to use a variable. So I've written this code here. If I want to enter multiple students' score and then print out their grade, I write a for loop. Here I use this for loop. And then I have to so if I have to produce multiple students score to grade, I could do the code this way and use this block of code multiple times. I could do this way, but it's lengthy. It's not doesn't look professional. So a good rule is always use one block for just one function. For example, this for loop, you scan the scores, and then you use a function to encapsulate this part. This part is for calculating the grade. So in these situations, function comes handy. It helps us to break down our code into small chunks and to focus on one function for each chunk. And also it increases the code usability. So for example, here I can take this out and the input should be a score or a here because I use the score, so I just use this one. And now we can reuse this code multiple times. Just cite this. You usually write the definition before you use it. So the function really allows us to break down the code into small chunks, and it will be easy for other coworkers to understand. And we can add comments here, what this block is for and what this block is for. Okay. Function, it's pretty intuitive. And the next one, I want to talk about a recursive function. If you have learned the algorithm, it's an important concept in algorithm. It helps us to make the code very, very short, very minimum amount. And in some situations, it could come very handy. For example, here, I want to calculate the factorial of a number. So the factorial of a number equals the number and the times are all the way to 1. If we observe this formula, we see factorial of n equals n times the factorial of n minus 1, right? So this could become n and times f and f factorial of n minus 1 equals n minus 1 times the factorial of n minus 2. So, and the recursive function allows us to repeat this until it reaches the base case. When do we stop? When we stop when n equals 1 or 0. So in factorial, in a recursive function, there are two components. One is the base case. It tells the function when it should stop. And the second one is the recursive call. It tells the function the relationship between n and n minus 1. So for example, here, in this we could write when so when it's n equals 1 or n equals 0, and it returns 1. And if we don't use the recursive function, then we would write a for loop, and then it calculates. It should be will be for I in the range and 0 to 20, then it will loop should write the n, and then it will loop from times from number 1 to times 2 until you reach the number n. But in the recursive function, we don't have to write a for loop. Instead, we use this. Just to set up the base case and then the recursive phone call. So just use this. And then sorry. Let's see. Is that Salam here? Let's see if it works. Tells us it's not supported. So I guess the problem is here. Everything looks correct. So here it works. The return. So it can record the next function. So another situation we often use a recursive function is the Fibonacci number. Fibonacci number is the n equals, for example, here. The list of number. Just use this. Fibonacci number is for example 0, 1, and then next n should be n equals the sum of the previous two numbers. To reconnect this. Give me a second. You can practice the code we have while I'm reconnecting to the screen. Oh, so
Fibonacci numbers are composed of numbers from the sum of the previous two numbers. But the next element should be 5.
if we look at this, it's a good case for recursive core.
Because Fn equals Fn minus 1 plus n Fn minus 2.
So this is a good case for recursive function also. If we define this, we change this, we can do actually. Again, we have the structure is the structure is a base case and a recursive core. So let's write the recursive core first. The recursive core is should be like I said, it should be Fn equals Fn minus 1 plus Fn minus 2, right? N should be N minus 1 and plus and here the base case is when N equals 1, it should be return. N equals 1, it should return 1, and N equals 0, it should return 0. So I think it should be different. Return N, yes. Test again. Oh, here. Obviously, so. Looks there's still some problem. Oh. No, it's correct. And also you can add a print to print out all the numbers. So this is a recursive function and it could make your code very succinct. But actually it doesn't improve the efficiency of the code. If you calculate the big O, then it should be the same, usually it's the same as a loop statement. Next, we're going to talk about classes and objects. For example, in our example of students and their record, we have multiple students, and each student has their name, a score, or some other variables, and we could create each student at a time and then give these variables to them. It will be a lot of repeated code. So in such situations, it's good to use classes and objects. This is very important if you proceed to develop a big program. Yeah, there will be a lot of classes, and you want to make your code reusable and adaptable. For example, in each class, for the student class, there will be different types of students, an undergraduate student and a graduate students. They are different objects and they will have different attributes. So, and the class and the objects allows us to define the class with the same attributes and like names or programs, but also allows us some flexibility to add attribute. Maybe an undergraduate students can have some example, maybe assistantship, or the graduate students versus have an assistant, graduate assistantship or whatever. But it does allow us to have reuse the code and also adapt from the class. For example, here I create a class. A lot of you did this, which is very good. The class, the name of the class should always be capitalized. We could just create an empty class.